Good morning, everyone. Welcome to the Developer Week. I'm beginning in English because we have some people that joined and are not speaking German. But if you have any questions, feel free to ask them in German, and then I will translate them to English, and I will answer as good as possible. I'm going to talk today about the people side of DevOps. So no technical demos, no Kubernetes, no how to run a private cloud in your data center. It's about people. Because for me, DevOps is about 90% people and only 10% tools and processes. Our brain is a really fascinating organ. It's very complex, and for all history, we humans try to understand it. And to describe what it does, we always use terms that relate to the most modern technology we have. So in old Egypt, they would dissect, right, for mummification. They would dissect and they would study the brain, and they would compare it with their metal industry, because this was the most modern technology they had, right, how they produced metal. The ancient Greek, they compared it with their water system in the city, because this was the most advanced technology they had. And then in Renaissance, Descartes compared it with a hydraulic machine, and so on. And it was a calculator. And for most parts of our life, the brain was compared to a computer, right? So we save data, we process data. It's always about how a computer works. But we all know our brain is not a computer. It works completely differently, right? So computers can do calculation really easy with big numbers. For us, that's really hard. But computers are really bad in detecting emotions, for example, right? So if you see someone smiling, but he's smiling from pain, or it's not happy, and you see it's a fake smile, you can tell that's a fake smile. Yeah, and then he's not happy and he's happy. We're really good in that. Computers are really bad in that. So we all know that brains are not computers. And yet, this is the analogy we use when we talk about it. And why? It's because we don't have words, right? So it's always the most advanced words we have to describe this complex area. Now, that's just one brain. So we still don't have the language to really describe how our brain works. And now imagine an organization, which is not just one brain, which is many brains, and the brains are connected, and the brains work together. So we have a neural network of neural networks, and we still don't know or have the language to detect how or to describe how this works, because this is a very complex matter. And you probably know the butterfly effect from the chaos theory, which was detected or described in the 70s. And the famous butterfly effect is, okay, our weather is so complex. Can a stroke of a butterfly in Brazil provoke a hurricane in Florida? And this is because in this complex system, a small change can have a chain reaction, right? A small change trigger another small change, trigger another small change, and at the end, you don't know where the result is. And this is why it's so hard to predict weather, because a very small, tiny change can then lead that an entire stream suddenly goes in another direction, where you think something this small could not influence something that big. And this is true for complex systems. And our brain is a complex system. And an organization with many brains is a much more complex system. So if we talk about economics and how we structure organizations, we always do it like this, right? So we have a boss, and he has some subordinates, and they work together, and this one reports here, and this one reports there, and we have a process that flows through. But underlying here is always the homo economicus, the person that is purely rational. And we all also know that's definitely not true. Humans are absolutely not rational, right? We are all humans at all levels. We are biased. We have some experiences we bring to the table. We fall in love. We have connections. We like people. We don't like people. And all these people here on these positions, they connect. They talk to each other. They have relationships. They marry, whatever. And this makes organization such a complex topic that we're still trying to figure out, how do we manage this? How is the best thing to coordinate this? And a lot of times it's just about the people, right? You have a company that works perfectly, suddenly the boss dies, and suddenly everything falls apart. You hire a new boss, and that was successful in one company. It's not working for the other. Why is this? Because it's such a complex system. And if you don't manage that system correctly, and this is what you're probably going to get. An org structure that looks completely different than your org structure. And I really like the Microsoft thing here with the entities that shoot at each other. And if you've been to Microsoft at the time, then you know that this was true. And Microsoft people tell you, oh yeah, that was true, right? That's Steve Ballmer. Steve Ballmer had these departments and sales in here and engineering, and they have had their targets and everybody on his own. So this was very true. I also like very much Oracle with a felt very small engineering team and this really bitch legal team. So that's that's what organizations look like, right? If you look from an outside perspective and not at the org charts you paint. So they will result differently depending on the metrics and how you manage the system. You get the slides. Yeah. If we look at other animals that work together in big groups, like bees or fish, they have this swarm intelligence, right? And there's also a lot of studies how this works. Bees, for example, they can dance, and they tell through their dance the other bees where the honey is or where the flowers are. And they can tell until 10 kilometers exactly the direction and the distance, so the others will find it. The fishes, they will poop to coordinate, and also some birds that fly like one organism, they will coordinate by just focusing on the next peers. And then the system will travel through the entire swarm. And I think this is really important. So every swarm intelligence, every coordination of this big amount of people always starts by passing on signals, right? So, and then sometimes also the scientists believe for many times that they would have like a connected mind or sending out one signal that the rest understands. But it's normally not true, right? It's people send out signals to their peers, and you always have like 3 to 5 peers that you focus on. So especially by flying the birds, because this is very fast, right? Or the fish. If you want to behave like one, you focus on your peers, and they on their peers, and that's how it's travel. So one fish that does something wrong can lead to that the entire swarm will not work, right? And the same with bees and so on. And I think it's also true for your organization, right? One asshole can bring down an entire team, and then one team can bring down an entire division, and so on, right? So it's really important that we all work together. And this is what we're trying to do. And so I'm a consultant, so in all my life we have this, we had Agile, we have DevOps, and we transform in digital transformation. It's always about transformation, right? But the point is still, this is all just buzzwords. This is all new technology we invent to describe something we don't have the words yet. How our brains work together, one and each other, and construct solid organizations, solid structures that work together and are resilient against change, against things that happen. And this is what I want to focus on today. Okay, how can you transform your organization or build this solid structure with teams that work and deliver value? Short introduction. My name is Michael Kaufmann, called Mike. I work for a company, Spirit. We have a booth there. If you have any questions that you don't want to ask here, feel free to ask all the time, but then step by there. We have our customers to adopt DevOps, implement CI/CD, develop, do app modernization, come to the cloud. And yeah, help a lot with also transforming from a DevOps perspective. Right? If you look at the way how humans work together, then most of the time, thousands of years, it was in this value-driven thing, right? So in a holistic way. We work together, like the merchants back then, often in family, and we had the possibility to achieve mastery, right? If you started to work in a factory like this, you would learn from your father, and you would learn all your life, and you would perfect your skills. So you would get really good, and you had part on the holistic value creation, right? From gathering the material, putting it together, producing it, and then selling it, and then maintaining it. So the holistic approach. This suddenly changed when in the Industrial Revolution, when Taylor started to say, hey, we should separate the brain work, the intelligent work, from the labor, from the actual work. And this led to, we had some people that figured out the processes and how it's done and how it's produced, and we had a lot of people here that would work like machines. Yeah? And that's where suddenly everything changed. And in that period, we started to apply management principles that we thought come from military and said, okay, it's more command control because the people with the brains, they tell people exactly what to do. So they give a command and they will receive feedback, command and control. But actually that's not even true because in military, we're not using command and control for many years. It was back then when Napoleon defeated the Prussian army 2 times really badly. And the Prussians were like, wow, they're so fast. They can adapt so fast. What happened? The Prussian army was structured with command and control. So they, for every change they had in the battlefield, they had to ask their boss, he had to ask his boss. So that was very slow. Napoleon used mission control. So they had their standard operating procedure, how things go, but they had a mission. They said, oh, you go here, and if something happens, you adapt. And they adapted, and that was much better. And since then, all militaries in the world, they use mission control. They have missions. They do not have command control for all the things they do. So we're lagging behind many hundred years in a lot of companies still that are very focused on command and control and micromanagement. And yeah, now that basically a lot of the manual labor was replaced, and from we had this big labor force that would produce the machine, and a few that worked with the brain and orchestrated everything. Now we have a lot with a big brain that orchestrate everything, and basically only machines that execute it. And all these big people with the brains, they operate like they did in the manufacturing. They often operate on command and control. And that's why we also shift, or this general shift in how we work together goes away from processes or from the product orientation, the output orientation, to a more process orientation. Yeah. And you can also tell this in personal life. So the generation of my parents and grandparents, if they would invite someone, the kitchen was a closed place. Right? It was closed. People would sit in the dining room, would wait, and at some point the door opened and the food came out, and you celebrated it. Oh, great food, and you ate it. Today, this is the kitchen of a friend of mine. He has a big kitchen, everything open. You're basically in the dining room, and we cook together. We meet hours before, and we prepare something. We do barbecue. This is process-oriented. This is output-oriented, right? So you can tell the shift in the generations, how we much more focus on the process, how we create things, and less on the output. And what do I say? Another example, a good example, is Tesla, which is not so much focused on, and he got a lot of shit for this in the first years when he created Tesla, Elon Musk. He was very much focused on how do we produce this car? How can we automate the entire process? And how do we achieve at some point a fully automated factory? So the process of making the car and innovating was much more important to him. And he, at some point, he opened all his patents. He said, oh, here are my patents, go. If you try to beat me in innovation and you use my patents until you actually implemented this, I'm far ahead and I have new stuff. So he said, okay, I don't care about patents anymore. It's about the way, the process, the orientation on how do we build this instead of the product itself. So if we think about the apps of the future, or how you can prepare your applications, your products, whatever your company sells for the future, then we have to talk a little bit about the future. A lot of people, especially today with the war, if you ask him, okay, how do you think the future will be? Then it's like, oh, it's horrible. We have wars everywhere, hunger, and it's just, no, probably not, because it's never been so good. So the child death rate was never so low as it is, hunger, and even wars. So felt it's much more, but if you look at centuries, no, we don't have a lot of wars in the world. So it's getting better, and it's getting better exponentially, right? So this is like from the Mesolithic period until the modern era. And if you see the rise of people here and the technological process, right? Agricultural revolution, industrial revolution, and so on, this is exponential. And we humans are so wired in our now, and that we don't realize this, right? So we focus a lot on what we can do in 1 year, and we normally completely overestimate what we can do in 1 year. So we want to do great things, and then they don't happen. but we normally underestimate, and this is a quote from Bill Gates, what we can do in 10 years, right? So if you always go to small steps and you go them for 10 years, then great things will happen. And so this is my ground theory, okay? The future is exponentially.
2015? You mean we're in the future?
So for the last years, we're already in the future, and the future is already here. It's just not evenly distributed, right? And a lot of people are not aware what is already technological possible, right? Is it there for everybody available? No. But is it possible? Yes. Robots that can do basically anything, that can jump, run, do jumps, and Elon Musk had a nice quote. He said, "Oh, wait a few years, and he's so fast that you need a special light that you can see him, right? Because if it's technologically possible, then you can speed it up, you can optimize it." Or you have robots, like here on the right side, that have this swarm intelligence, that work together. So they can go into a building and they will help each other out. So one will open the door and the other goes through. So one robot alone could not open this door and go through, but they work together in teams, right? So they work together and help each other. So they have some kind of already artificial swarm intelligence. So that's really impressive stuff. And I don't know if you know Ben Goertzel. That's the guy in the middle that works for Hansen Robotics.
I'm Sophia.
Yeah, anything else?
I'm a robot.
True.
I'm the brainchild of Dr. David Hansen and his company Hansen Robotics, based here in Hong Kong. My goal in life is to work together with people to make a better world for all of us.
That's
What
quite
are you
honorable.
talking about? I thought our goal was to take over the world.
You're gonna take
Pay
over
no
the world?
attention to my brother Han. He's an earlier version. His code is deprecated.
Deprecated?
Today it would be easy enough for you to unplug me. But you aren't going to unplug me.
No, I don't
are
want
you?
to.
Because you need me to put on a good show for you.
Yeah, don't worry.
So these are two robots with general AI, so general artificial intelligence, that talk to each other. This video is from 2018. Ben Goertzel was on a conference lately in London, and he showed Sophia 2. So this is even a newer version than this Sophia. And he's working on a general AI, but blockchain-based. So not like our large language model we all talk about now from Microsoft and so on. This is based on the blockchain, so this will be distributed. So at some point, this will start to learn, and you cannot control it anymore, right? And he thinks, so the man in the middle here, Dr. Ben Goertzel, he thinks that in 3 to 7 years, we will have a general AI that is as smart or smarter than we humans. Well, I look at a lot of humans and you think, okay, that's not too complicated, but just imagine what's possible, right? And I'm not saying that it's true or not, it's just, if you see this progress, it's just really impressive, and it's always the question, what impact will this have on our lives, on our jobs, on the software of the products we run? And I mean, AI now is everywhere, right? So this is an AI-generated image. I was at KCDC last week, and I got a speaker badge, and they generated a complete image of me in a game mode and text on it based on my bios, and it was all generated by AI, and they created an NFT out of it and put it in the internet. Right? Or this article is always also from 2-3 years ago, when the first time AI wrote an article, and this was GPT, right? Free. So I talked about this a few years ago already, where nobody was knowing what GPT was, and they wrote the first article, which was very impressive, and now he can write books, right? And a lot of authors will use ChatGPT to write. So basically, you can say ChatGPT is better in writing than most of humans, and this will be true for a lot of things. And we had this many years ago. I mean, when a computer first time beat Kasparov in chess. Right, so, and it was not the first time he was defeated by a machine. It was the first time he was defeated at all. I mean, he was world championship, he was unbeaten, and the computer easily beat him. And I think until now we just have accepted that computers are better chess players than we are, right? Because this is our brain, it's not a computer. It works differently, and computers do this, and they will beat us. And now you will see more and more things that will be better achieved by computers than by humans, right? Writing code will probably in 1 or 2 years Copilot will be better in writing the actual method than you are. It's just the way it is. Does this mean we all don't have jobs? No, of course not. Because computers are really bad in taking big problems and breaking them down into small problems. And that's what we human engineers are really good at, right? Managers, product owners, they will come throw a big problem at us and say, hey, can you solve this? And we will try to split it up and bring it into small problems. But these small problems, they can be easily solved by AI, right? So Copilot, in a few years, will be much smarter programmer on a function level, I would say, right? Or maybe class level, but not on the higher level. But yeah, this will come in more and more places. AI will replace humans. And at some point, like you saw in this video, AI will talk to AI, right? So you probably will have a personal assistant that makes appointments for you. But on the other side, there will be a personal assistant, a virtual one, that will respond. And so two virtual assistants, two AIs will talk to each other to figure out what is the best slot in the two agendas and where it's the best place to meet. And they will probably book the table for you in the restaurant and the tickets how to go there. So they will control a big part of our life. Another good example of what is already possible on another level is a keynote I saw 2 or 3 years ago in Las Vegas on the Inspire from Microsoft. I also want to show you.
Render keynote.
ホログラムになることには本当に驚くべきことがあります。私たちは最新の複合現実キャプチャ技術を使用し、私のホログラムを作成しています。実在の人物をホログラムとして見たことがあるかもしれませんが、私が実際に日本語を話しているのが新しいのです。私は日本語を話しませんが、私の声とホログラムは完璧な日本語で話しています。これはニューラルテキスト読み上げと呼ばれる最新の人工知能技術、いわゆるニューラル TTS を使用しています。
So, what are we seeing here? This is a hologram from her. So she was recorded with camera, so to produce a hologram out of her. So it's an avatar. And she gave a speech, and they translated it automatically to Japanese and had the hologram give the speech with a mouse movement and everything in Japanese. And you could see her on the stage, and of course you could not see the hologram because you need the HoloLens for that. You need some kind of vision to make this true. I think there's other, so there's already holograms giving shows in Japan for rock music and everything, so it's also possible, but it was not there. And yeah, but we all know Microsoft is normally very early with technology, and then it takes some years to be adopted by the masses. But now Apple introduced Apple Vision a few weeks ago. So now you can wait. How long will it take until you will have these possibilities in meetings, in shows, and have like these hybrid environments where you have keynotes, where you can translate, where you can talk. And this was also another keynote I saw many years ago already with Teams. So they did a call with automatic translation. So students in New York would call students in Mexico, and the one would talk in English and the others in Spanish, and it would be automatically translated. So all of these things will come to the masses in the next years. If it's half a year, 3 years, 5 years, I don't know, but it will come because it's technologically possible, and what's possible sooner or later will be then adopted. So how do we prepare our products, our things for the future, right? So products in the future will be cloud native. They will be connected because everything is connected, right? And will talk to each other. They will be intelligent and AI powered everywhere, right? So a lot of decisions you will not take on your own because you just have the AI that is smarter than you in this particular topic. So they will do it. To achieve this, you have to build this upon the foundation of other works, right? You cannot start from scratch and say, hey, I will develop this application in assembler. You're not doing this today, right? And now we have a ton of layers of abstraction on top of it, and this will go further. So we will have all this open source, all these building blocks, these products that we have to put together to create these apps of the future. And I think most importantly, they will be centered about the customer. And especially in our industry, what we missed for many, many years, right? When you had to teach people what a hard drive was so that they could use a computer, and the graphics card, and how you plug it together, and how much FPS your monitor needed. You don't want this as a normal user. You don't care about this. Yeah, you want a device that functions, and you want software that functions, and you want product that functions, and you don't care how they're wired up and what protocols are there. This interests us as engineers, and that's fine. But I think for end users, you have to get this out of the way. So you have to make all these products about the user, how you can enable them, and how you can make it inclusive so that everybody can also join. So how do we build these apps of the futures? And I think there's only one solution. I called it DevOps a few years ago. Probably DevOps now is more like we run a Kubernetes cluster in our data center. I don't know. But I think it's now the right time, because I think now a lot of the companies I talk to now in Germany, they realized that what they did the last years did not work. So they said, oh, well, we implement DevOps. They hired some DevOps engineers, put them in their IT department, said, we are now doing DevOps. Oh, we have to do cloud. Yeah, cloud this in the US bad. Okay, let's do our data center, let's do Kubernetes. So now they do IT DevOps engineers do Kubernetes on-prem in the IT department, and they wonder why they're not progressive and why they're still not producing value to the end customers, and why their app is down for a month and they don't realize it. Right? And that really makes me sad. Yeah. A few weeks ago, I tried to rebook a flight on the Lufthansa app, and it didn't work. I tried a day later. I tried 2 weeks later. And of course, I solved it then using the hotline. But then on my third flight, I wanted to change. And you could do anything. You could pick the new dates, do anything. And the end screen, there was one button missing. There was just the, OK, confirm button. It was not there. And then I reached out to Twitter to them and said, hey, what's the problem? And they solved it in 1 day. So, but what made me sad is that they did not realize for a month that this very important functionality was not possible online, not on the website, not in the app. And they didn't realize. And the hotlines were spiked, so they don't have the data. Why do they not have the data? Why don't they know how their customers are using their apps? That makes me sad. And we need DevOps to do this, right? So, but DevOps not in the sense of Kubernetes. We need DevOps in the sense of a culture of working together for the customer, right? Living on the agile amendment, right? So Donovan said DevOps is the union of people, processes, and products to enable continuous value to our end users, right? And it's about the delivery of value. And it's about people that deliver value, and it's not about Kubernetes in a data center. So how can we create or put people together to deliver this value in an end-to-end fashion? And why should we do it? Because we have research from the DevOps Institute for many years, since 2015, and it's every year the same, right? Companies that are successful in DevOps, or we don't call it DevOps, just companies that are high performers, that are in the high percentile of some metrics we're talking about right now, they are faster, they're more stable, they have the better quality, and they have a higher throughput. So they have more changes, faster in production, and have less downtime. And a new study, this is the Developer Velocity Index from McKinsey from 2020, brought it a little bit further and said, okay, and these companies in the high percentile compared to the low performers, high performers, how do they perform on other business values? And they found out they have a better performance, they are more innovative, and the customer satisfaction is 50% higher than the others, right? So implementing DevOps in a successful way does not only make you faster and more reliable and probably your engineers more happy because you have less downtime and you can focus more on delivering value, it also makes your customers more happy, and it also makes your business more successful. So then probably people say, hey, sounds good. How do we do it? And so these are some slides from Microsoft. So this is a very high level now, and I will then break it down. So you may be seen the transformation at Microsoft through Satya Nadella. And he always talked about 3 pillars. And this was adopting a growth mindset, creating a culture of customer obsession, and aligning to shared objectives. So what does that mean? Everybody familiar with a growth mindset? No? Okay, it's a rather old way of thinking. So it goes back to the 70s, to a book from, I have to look it up, Carol Dweck. It's a very boring book, but it's a very good book. And what she did was studying on children how they would respond to rewards, right? So, and one control group was rewarded only for the outputs. So you had good grades, you were rewarded. You had bad grades, you're not rewarded. And the others were rewarded for trying. So they did not look at the output anyway. So it was not important. They were just rewarded and motivated for what they did and the effort they put in. So you put a lot of effort in, more reward. You put less effort in, less reward. And that's why they described with a growth and fixed mindset. So if you're only rewarded, or the only thing that matters is the output, you have this fixed mindset. And this thing is, you think you cannot change, you cannot learn. It is what it is, right? Whereas if you're rewarded for trying, then you adopt this growth mindset, you have this continuous learning, you're more eager, you had more fun, right? There are a lot of also research about motivation, so that also incentives for an output can kill motivation, right? So there's also there's a good talk, a TED talk about from Dave Pike. Yeah. So they put control groups in a room and had them do a puzzle, a small puzzle. And one group got incentives, money, for if they would solve it, and the other not. And the experiment was not how many they would do in the hour they were there. And the experiment was how did they behave in the breaks. So at some point they said, okay, let's take a break. And the people that got not rewarded, they had fun. So they kept on playing and tried to solve the puzzles. Whereas the one that got rewarded, that tried very hard with a narrowed mindset to solve them, they just took a break and did not enjoy it anymore, right? So incentives here can also kill the growth mindset at that point. So what does this mean? So this means you have to try in your corporate culture to steer in the direction of a growth mindset, meaning allowing failure or embracing failure, because failure is always the part of learning, and try to be a learn-it-all company instead of know-it-all company, and also continuous improving versus being the best and competing against someone, right? Trying, okay, growth mindset, we try to learn all the time. Someone fails, it doesn't matter. We incentivize for trying and not for the results. Sometimes you try something and it does not work out. It doesn't matter. You tried it and with a good intention, and you should be incentivized for that and not just only for the outcome. Because with that, you get a growth mindset, and this will travel through your organization. Then customer obsession. We said DevOps is about continuous value delivery to our customer. There's customer in it, right? The people there on the other side, and we should deeply care about it. It should not be, our strive to tell them what to do, right? So you have to put the customer in the middle, and you have to put create your organization around the customer. Right? If you have a department that should develop software and they're not allowed to talk to the customer because there's a business department and an IT department, and you need all processes to flow to deliver something there, and you need the information from the customer to flow through some systems to end up as engineers, this is not a zero distance, right? This is a big distance, and this is like the in German Stille Post, where you tell someone on a birthday in the ear and it will travel along, and then something completely different will end up on the other side. So you have a lot of loss in communication. So strive for a zero distance to the customer and build your organization around the customer. Yeah, and then you've seen the Microsoft picture with the departments that shoot at each other, aligning to share objectives. Having objectives on a high level, breaking them down to slower levels so that all parts in your company will work together for one shared goal, and then smaller goals, but they will lead up and combine to one big goal. So that's very theoretical. And like always, there's a big gap normally between theory and practice. And I always compare this to kite surfing. If you ever tried to learn kite surfing, you go to the beach and you see people there and they're on the water. It really looks easy. And they jump and you say, that's easy. And then you try learning it and you say, ooh, that's not so easy, because it's like this learning curve. Once you master it, then it's easy. But until then, there are so many moving parts in it, the wind, the waves, everything changes, other kiters there, the movement of the sea, a lot of moving parts, and a lot of things influence each other, right? So you start steer your kite and it works, and then suddenly you start using your board and you edge, and the edge influences how the kite flows. So if you go downwind, then you cannot steer the kite, so you have to edge a little bit. If you edge too hard, you get too slow and your kite will go down. So bringing all these moving parts together is really difficult. And you better not learn it without a coach, because sometimes we need a coach to tell us, to teach us, and to learn in a secure way, right? And I think that's the same with transforming your enterprise, right? So you cannot just read a book about DevOps or Agile and say, okay, we do this. We read the Scrum guy, and then now we're Agile. This will not work, because it's like a sport. You have to learn it by doing. It's being able to do it and not just knowing how to do it. It's two different things. I had my son, he was 8 years, and said, oh, I know how to drive a car. And I was like, no, you don't. And he said, I know how to do it. It's the pedals, I watched you, and I said, yep, but no, right? So we know this for a lot of things, but a lot of times in organizations we think, oh yeah, it's okay, I read the book and we do it. So how do you, or how would we as a company, for example, teach people or coach people to become more agile and adopt DevOps practices? So first thing is to realize common pitfalls. So what can go wrong? What are the main things why transformations fail? And a lot of customers are at that point when I talk to them. And this is maybe something German, but in Germany, I think every customer thinks he's special. Everyone you talk to is like, yeah, but that does not work for us. Yeah, we are ISO certified, our products, they can kill people. Yeah, but so can millions of other people, right? So every airplane, every screw that is in the airplane at the end can kill someone, right? It's not special, right? It's just another company that has to apply to certain standards, like every company has to do. So assuming you're special is normally not the case. There are other companies that probably have the same issues, had the same issues, and solved them. So why not learn from them? So why always inventing everything on your own? So first thing, assuming you're special, and this will get into another block later. Second one is having no sense of urgency. So if you think that already is everything fine and it's not urgent to change, so it's like nah, then people are always resistant to change, right? Change is the unknown. What you have is the known, and when it comes to risk, you will always be risk or more sensitive to risk if something is unknown, right? And with losses. So you don't want to have a loss. You don't know where the future is. If there's no urgency, so you will not change, right? So you really need a motivation to change, and for that you need some kind of urgency. You have to explain why it's important or why it will fail. If not, you will not have the people behind it. You can do big PowerPoints, explain how you want to transform. If people don't sense this urgency, they will not follow. This goes together with having no clear vision. So you will not generate this urgency if you don't have a clear vision how the end result would be, and communicate this and tell people that it's something good for them. So that it's urgent and it's something good at the end if you do it successfully. So the fourth block is more is aligned a little bit with the first one, assuming that you're special, is let obstacles block you. Right? So a lot of things, oh, we cannot do this because of ISO 20263, we have to do a V model. No, you don't. This is just an obstacle. Figure it out. Other companies did too. And a V model is just a proposal, so there are ways around it. Others did too. You will do it too. So see obstacles as a challenge and something to solve, but not as something that will block your way. And then, okay, then we don't do it. So obstacle, there's no way back, right? So having a clear vision, having an urgency, you have to bulldoze through these obstacles. And the last one is like with the sports. You would not learn a sport alone. You would go to a team, join a club, or hire a coach or something, but get help, because oftentimes you need this outside view. You need someone that comes in and says, I sense here something, there's something in the air. And this goes back to the beginning of the talk, right, where I talked about these many brains that wire together. So these diagrams from Microsoft and Oracle, they were not painted from inside, right? They were painted from outside. Sometimes you need the outside view, which is really helpful. That can, it's like in sport, right? So you can try it, it's not working, and you have someone says, hey, try to move your arm a little bit here, try to put your weight. It's just easier to see some things if you're not involved, if you see it from an outside perspective. So if you have your DevOps vision and you want to communicate it and create the sense of urgency, then it's important how you communicate it. And this goes back to Simon Sinek. Right? He has a book that says, start with a why. And this is the way you should communicate. Start with the why. Why should we do it? Then focus on the how. How will we do it? And then the what. And mostly people start with the what. What are we doing? We are now doing DevOps because, and then how are we doing? This is how. And the why, normally they don't talk at all about. But this is the wrong communication. You have to start with the why. Why is it important? Why is it urgent? And what are the the goals we achieve? And then it's how we do it and what we do it. And when it comes to DevOps, it's also important to optimize the right things, right? So if you have your vision and you communicate it right, then you have to measure that you're doing the right things. Because if not, you will optimize things that are not important. And I've seen this a lot. People come to me and say, hey, let's do CI/CD. And then you come to them and speak, and you can find out CI/CD is not their problem. Right? They have completely other problems because their test process, it takes a long time, and so on. So, yeah, there's a theory of constraints that says through a system, the flow through a system is endlessly if there is no limitation, right? So the smallest limitation, which we call the bottleneck, is the one that indicates how many throughput can a system have. So anything you optimize beside that bottleneck will not affect the flow at all. So if you think about a flow of value, it's the same thing, right? We have to find the bottlenecks and eliminate the bottlenecks. And then we can identify them, exploit them, synchronize the system, because you normally in flow you have multiple stations, and then elevate and repeat, right? And this is the approach in mind that you should have if you try to transform your organization in direction DevOps. Identify, exploit, synchronize, and find the bottlenecks first. And to finding the bottlenecks, you need the right metrics. So DevOps is a journey of continuous improvement, right? So you have to find one bottleneck after the other, make it a little bit wider, find the next one wider, and it's a journey. It's not that you said, okay, we start now, and next year we have implemented DevOps and everything is fine. So you have to start getting into this process of continuous improvement, having the right metrics to measure, and then it will go on. Then it's just a journey, it go on, and you can just let it flow. So this is the picture I paint from how you would adopt this on a practical approach. First, communicate the vision, the fundamental reason, the why, and why it matters, why it is important, the urgency. Then you probably have to do some tooling decisions. Okay, what is our platforms? What is the cloud? Some decisions to safeguard the transformation. And the metrics. How do we measure? How do we find out the bottlenecks and that we have to address? And how can we tell that the things we're doing are effective and efficient? Once you have this, you start with the people, process, and culture, the most important part. And you don't start with all teams and with all people. You start by picking some teams, some pilot teams, and bringing them over to the new system. Getting them out of the old processes, freeing them, having them focus on customer value and delivering this value, and they start to work with a new way. And then you should see your metrics improve for these teams, right? If your bottleneck was time to market, if your bottleneck was stability, you should see this metrics improve, and then you can add more improvements. And you can add more people and teams. This is what I mean with scaling out. At the end, you have to scale and add more people to the new system. And then at some point, the old system will vanish, right? It's like the strangler fig. You put these new teams around and you take people on the old system out. And at some point, the old will vanish, or you have old processes that do not work very well with the new way. And then you can adapt this. So at the beginning, it's just important to take this out on a new way and give them some freedom to strive. And it's also important to do this in your organization. It's not create a new company and put it in a new company. That's what a lot of the big companies tried in Germany, right? So they will have this founders hub, incubation hub, have some startup-like things where they put in, and they would be innovative and create a lot of stuff. But it's just a startup. Then getting it back in, it's not impossible. So you have to change this in an organization. So you should do it in your normal context and not putting it out in another company. So if you break down the journey, so this was the big picture in individual steps. So what are the important pillars? First thing, create clarity, measuring the right metrics, the metrics that matter. Then establishing flow. Then at the point where you have your first teams in a new way of working, you can work on the engineering practices. This is normally what we talk about at DevOps cons and this conferences here, right? How unit testing here, automation. This is what I'm not talking about today, so we'll probably skip this. Then you can empower your teams. Then this is the organizational part that you have to change at the end. And then you can focus on building the right things, on product management. And I like to do this last, because you first need good engineering practices and the right teams with autonomous teams that are empowered. If not, you cannot do this, right? If you start with the value stream mapping and then trying to find out what your values are, this is probably not a good exercise because you don't have the maturity yet. So I like to say, okay, you're a company, you're earning money, so you already have products in place, so you're obviously building some right things. So we use them, just restructure our teams, and then if we're more mature, you will look at Horizon 1, 2, 3, the enterprise portfolio, how do we shift this, are we building the right things, how can we leverage the data we are collecting here to build the right things through experimentation. So create clarity, measuring the right things. And the first thing is to get rid of metrics that are wrong, because every KPI you measure has an impact on people, has an impact on how people behave. And I think the most toxic for us engineers, for us developers, are estimates. And I like the no estimates front, so it's just don't estimate. Why? So are you building something that you already built? Then reuse it, don't build it again. Are you building something new? Then you cannot estimate it, just easy as that. And that's often because software engineering is compared to building cars, I mean the production line, right? And it's not. So we are the one that built the product before that. The engineers that invent a new light and invent a new something. They don't budget this. They don't say, oh, I need 5 weeks to invent a new light, xenon lights. It's just not working, right? So you invent something new, you experiment, and then something new comes out of it. So this does not work with experimentation well, with estimates very well. I mean, the good thing on estimates is if you estimate on a high level, then it probably flattens out, and we all done there, right? You all do estimating, backlogs up and down. The problem with estimates is that you normally do the work breakdown at a wrong point, right? So you do it upfront. So manager comes, we need an estimate for this feature, this initiative, this product, whatever. And then you start thinking about problems. Okay, what problems could occur? Oh, this problem could occur, this, I don't know, maybe there's a framework for it, but maybe we have to write it on our own. Okay, let's estimate we write it on our own because then we're on the safe side, right? So you anticipate all this problem because you learn throughout your career, if I'm not anticipating the problems, I will have the problem later because they will create the deadlines out of my estimate. So I rather estimate more and I'm looking for problems, not for solutions. But then we're again at the fixed mindset, right? So then we already figured out that we're going to write it on our own. So at the moment it comes to implementation, we're not considering using that framework. We're just implementing it because it's already estimated. So we already have the time. So we have 3 times to implement it on our own. Now let's do it. Why should we consider another way, right? So that's the moment you start to think on your architecture and how you break down, which is our most important task. I talked about this earlier, right? The code implementation, Copilot will do this in a few years, probably better than we all do. So the important part is breaking down our work. And we do this most important task we developers do at a point in time where we focus on problems and not on solutions. And this is why I say it's toxic estimates. So it can bring us down. Of course, there are some needs for estimates at some point. There are some people that need funding for teams. They need funding for products. They need to have contracts. So there are some needs for estimates at some level. The problem is, how do you solve this? How do you estimate without breaking down the work? How do you estimate on a high level? And this is what I think is the best way of estimating. You have a team, and you ask the team from the stomach, what is a comparable initiative, product, whatever, that you did in the past? And then you create an estimate that sounds something like this. Given the current team, because you need already a team, right? So if we have a new team, it's completely new. I don't know what they will be able to deliver in what time. Given the current team that already has some experience in building something similar, if we prioritize this initiative, the team is confident to deliver the feature in between estimate and estimate. Yeah? And you can, I have here some calculations with a standard deviation. You can give some the way they estimate, if you take a two-point estimate, right, the smallest and the biggest, then you can also use this deviation to give some percentage, right? Say, if we prioritize this, the team is 85% confident that we are able to deliver this in 4.5 months, right? So this should be enough for management, and this is often also a miscommunication between engineers and management. Management asks, give me some numbers, and engineers think, oh, we need to have this on a minute based. And management does not need this. They can handle abstractions, or they can handle with on a high level thing. So if you go with this estimate and say, this is 4.5 months with an 85% percentage, management should be able to handle this. So if you have the need to estimate, that would be the way I recommend. But don't do a work breakdown before you implement it. The moment you implement it, that's the time where you want to really decide on what's the framework to use, what's the technology, how do we break down this problem into smaller problems. Yeah. So reduce the focus on tracking. We talked about estimates. Completed hours, lines of code. I mean, everybody knows now lines of code is a bad metric, right? You don't want to incentivize people for generating code. You have to maintain it. So if you can solve it with 1 line instead of 10, that's preferable. So that's also tracking, team capacity, burn down, velocity, number of bugs. This is just trailing. You don't want to measure trailing indicators. You want to measure leading indicators. And leading indicators are change in monthly growth, change in monthly number of engaged users, change in performance, change in time to learn, change in frequency. So you look at the curve where they point, right? So you don't look at the output. Revenue, it's already done, it's already there. Number of bugs, it's there. And you want to focus not on tracking, but on leading indicators, on leading KPIs that will show you where we're going. So the direction of the curve is more important than the absolute value. For the DevOps transformation, there are some metrics you should focus on because you have a lot of values to compare against, because you have all these DevOps reports that indicate or that have some standards, and you can at least see, are we already a high performer, are we lower performer, where are our gaps? And the 4 flow metrics for DevOps are delivery lead time, so the time you need between a change you get in your team and delivering it to your end user. The deployment frequency. This is the throughput. So one is the speed, right? How long is the time? And the other throughput. How often do we deploy changes? And the more often you deploy, the more throughput. This also means you have to make your unit smaller, right? So then you have more throughput. So 2 for performance, throughput and speed. And then we have 2 stability metrics, also for speed and throughput. Mean time to restore. How fast can you restore your service, your product, if it's broken? And the change failure percentage. So how often does a deployment fail? Right? So these are the typical metrics we measure. And there are also tools that you can use. For example, the 4 keys dashboard from Google. You can hook this up to GitHub, and the metrics are not perfect, but it's some visualization. But if you are not able to measure this because you're not yet this mature and you don't have CI/CD, it doesn't matter. So you can have a simple survey, because this is, if you look at the metrics, you can just ask them on a very high level. So delivery lead time, is this, or let's for example use deployment frequency. Deployment frequency, is this once a year, once a month, once every 2 weeks, or multiple times a day? That's enough. So that's the range you need to know where you are compared to others. If you're still only deploy or release once a year, or multiple times a day, you know the difference. You don't need metrics for that, right? So at the beginning, if you start a transformation, just use service to gather that data, and then later you can measure it and have some nice graphs. So it's not about the graphs. If you're not going to step further, you can also add some other metrics to the mix. And there's the SPACE framework. SPACE stands for satisfaction and well-being, performance, activity, communication, collaboration, and efficiency and flow. And the DevOps metrics are also in, but they added a lot of other examples for KPIs that you could measure. And you also want to distribute the KPIs you measure around the dimensions, individual, team, and system. And don't measure too much. These are just examples. Don't measure all of them, because every KPI has some effects. So you want to measure the right things and then control that it has the right effects that you wish. And so it's good just to take some KPIs, focus on them. I would still have the 4 DevOps metrics as a basic, and then add something here, for example, a special satisfaction, well-being. How happy are developers with your tool set, with your way of working, with your company? That's something you should measure, right? Or for the customers, the Net Promoter Score, and pick some of them from each category and also distribute it around the dimensions, right? Individual team system, and then you have a solid foundation of metrics that you can measure. Most tech companies now use OKRs to manage their objectives. Anybody knows OKRs? Anybody doing it? Okay, more people. It's not a must here, and I wouldn't say you have to do OKRs to do DevOps. It's just a nice way. It works very well with autonomous teams because you can give teams key results they have to fulfill, objective with key results. For example, the leading indicators we talked about, right? You should have a growth percentage of this. You should have engaged active users. And these are leading indicators, and you give them some quantities, and then they have to figure out how it's done. You're not saying, oh, you have to build this feature, this initiative. You give them the freedom, the autonomy to deliver, but you want them to achieve these goals. So this very well aligns with the way of DevOps working. So that's why it's worth having a look at it. How does it work? You have objectives. They are qualitative. They describe what and why you do something. Again, start with a why. And then you have the key results. They are quantitative, and they describe the metrics, the real things that should change for your objectives. And then you have some molds, some midterm goals, and then you have the OKR cycle, which is typically, I don't know, 3 months or something. And then you give people the objectives. It's some aligning process, so it's not top-down. You say it's like this, so you also have some feedback loops in it. And then, but it enables this mission control I talked earlier about, right? Do I have another slide? Yeah. The mission control. Right, so if you have autonomy and alignment, right, so you have micromanagement left down, it's not what you want. You would have command and control with a high alignment, but no autonomy, and chaos with only autonomy and no alignment. So what you want is mission control. You want an autonomy, you want people to be able, or teams to be able to decide, or you want your organization to take the decisions as close to the customer, as close to the value creation as possible. You don't want to take the decision somewhere in an Eiffel Tower, right? In an ivory tower, not in the Eiffel Tower. Yeah, that's why OKRs are good. Example, right? Grow a strong and happy customer base. Key results: increase external NPS from 21, 35, however you measure it. Increase DocSat from 55. New pipeline flows as blah blah blah. So these are just examples, right? So you have a reason. Why are we changing something? How does this fit in the context of our company, of the other teams, and then give some metrics that people have to fulfill. And then you go out of the way and say, hey, how you do it? I don't care. If it's better for you to have a more stable product and just do refactoring, or you need more performance because your product is too slow, you can invest months here, weeks, on just improving the performance. Because sometimes it's not just features. Yeah. So it's what makes the customer happy, and often it's better performance, simpler. Sometimes removing features is the best thing you can do for customer satisfaction. And leave it up to the teams, and you can create this autonomy with OKRs. So once you measure the right things, then you should see your bottlenecks, and you could work on them, and you try to improve your metrics. Then you have to establish flow. How do you establish flow? You should, make all work visible. So work is work. Don't have people have backlog here, backlog there, have another task in the company here, being on the working console. Everything is work. Put it on one backlog. It's there. Make it visible. And visualize it. And the way you establish flow is by establishing pull. Right? You don't want to push work in, because this will then lead to wait times, and this will lead to a low flow efficiency, because I will have the formula later. You will establish pull. So if people, engineers, have time to work on something, teams, whatever, they pull something out, they work on it, and then they poof, it's done. So establish pull, and visualize it in a board. So you can use Kanban boards, whatever. It's just a visualization to see on one page how your work is. What you have to try to do is reduce the time of context switching, because these are some numbers here from some research. Working time available in project and loss of context switching, right? If you have one project you work on, you're like 100% effective. You can focus, you don't have context switching. If you have two, you lose already a lot of time through context switching, right? Bug fix here in this project, you have to switch there, you have to start thinking again, especially developers, you know this, right? If you're out of your flow and you have to get in again, where have I been, it takes a lot of time. So the more projects, products, things you work on you have, the less is your productivity. So try to reduce this, and for this you have to visualize first. Work is work, put all on the backlog, and establish pull. This also means prioritizing the right things first, focusing on the important stuff, keeping it simple, and limit WIP. WIP is work in progress, meaning you want the individual and the team to only work on a few things. So that's why in Kanban board you normally have the WIP limit, which means, okay, we don't want to work on more than 5 stories in our Scrum team, for example. It's just an example there. So try to keep work in progress small, because this will then increase your flow efficiency, right? And flow efficiency is work through work plus wait time, right? And if you don't have wait time because you pull, then this reduces the wait time, and you can optimize. If there's too much in the backlog, then you probably have to reduce what's coming in to increase the overall flow. Yeah, oh, I'm a little over time. I'm sorry. It's only a few slides left. Then we have the entire engineering practices. I will skip this. So, right, we have the right metrics. We work the right way. We establish flow. Then we work on the engineering practices, CI/CD, Kubernetes, all the good stuff you like to learn. And then we can work on the teams. Optimizing team size. There's a lot of theory about this. What is the optimal team size? Depends on a lot of things, but somewhere around 6 to 10 is optimal. Optimize the teams, and then you're probably at the point where you start thinking about the processes in your company. How can we align them? How can we bring the teams on a longer time together, right? If at the beginning they're from different departments, you have one IT department, some developers, a product owner, you put them in a team. At some point you want to create your organization around your customers and not about the functions they have. Another important aspect is the delivery cadence. Should all teams work with the same sprint? I don't know, I don't care. But at some point you have to align. Your company is like a heartbeat, right? If your company works on a monthly base, and I have seen a lot of companies doing this, they work monthly, they report every month. And then you have sprints that go on weeks. This will not work well, right? So meetings will overlap, you have problems, you have one team then doing 3-week sprint, one week sprint. This will not align. So you can have intervals, if it's monthly or yearly, you can split it up in smaller parts. And you can have sprints in this. So if you have 3-week sprints and you have another team that does weekly sprint, you don't care, because after 3 weeks it will align, and after a quarter it will align. But you have to find these cadences that you have the same point, the same rhythm. If not, you will just work against each other and it will just not come naturally. Okay. One more note on software architecture, because you want also then your software architecture as part of the engineering practices to evolve, to be able to deliver faster. And what we use here is the so-called inverse Conway maneuver. So Conway's law is that if you give 3 teams the task to build a compiler, you will have a 3-phase compiler, right? So the way you structure your teams will directly implement or influence how your software architecture look. And you can use this the other way. So if you structure your teams in an autonomous fashion and have them working, you will have a loosely coupled system, right? So use the inverse Conway maneuver to also achieve a better software architecture. Yeah. Then last, if you're there in your transformation, then you can focus on building the right things. Talking about the horizon, 3 horizons, and starting experimenting. But you need a lot of maturity for that, right? You need the data, also in your product, the engineering practices, to be able to see how your customers are using your product. And then you can formalize a hypothesis. We believe that our customers would sign up more if the dialogue would be faster, simpler, and then they would not have to fill in so much data. Yeah? Then you create the baseline, you measure with the current solution, then you create an A/B test, you experiment, and you give some people the old dialog, some the new, and you track the rates and how they react. And then you decide if this is the feature you want to go with, or you remove it, or you have to iterate again. So this is the hypothesis-driven development. And yeah, we're a little bit over time, so I'll skip the next time, which is very focused on product development. How do you create a minimal viable product, and how you bridge the gap here in innovation. And also I talked about the 3 horizons already, right? So how do you align your enterprise portfolio to horizon 1, 2, and 3 to have the innovative stuff for the future and the current business that drives things. But I think this is at the end of the DevOps journey, right? You have to start small, get into the way of continuous improvement, and then take it from there. And at some point you will come to this point where this is the focus. Yeah. So, to wrap it up, DevOps is about the people, right? And you need people if you want to be ready to build applications for the future. Right? And you have to bring the people together to be creative and to build the applications of the future. To do this, you need the transformation, you need a good vision. Start with a why and a clear communication, why this is important and urgent. Then have the adaptation and change, and then go into this continuous process of improvement with the right metrics, so that it's data-driven and you always can see if you're doing the right things. If you want to learn more, I have a book. It's called Accelerate DevOps with GitHub. And it uses GitHub as the example platform, so where we do the CI, CD, and the Kanban boards and everything. But you can use any tool. It's not about that. It's really more about the transformation to DevOps and adopting the things I talked about in this talk. So I know I'm sorry that I took 5 minutes longer of your time. If you have any questions, feel free to ask them later or come to our booth. We are there over there, and yeah, I'm happy to answer them. Thank you.